Right now, reaching Mars takes about 9 months, but a UK-based company has designed a rocket that could complete that journey in just 4 months, and it recently completed its first successful plasma test. Until now, spacecraft have only had 2 real options. The first, chemical rockets, which launch from Earth with massive force, but their fuel burns so fast that they're only useful for short bursts of power, not for long, deep space journeys. The second option, electric or ion thrusters. These are incredibly efficient, but their thrust is so weak that spacecraft have to accelerate slowly over months. In other words, you either get power or you get efficiency, never both. That's the gap that's been slowing down space travel for decades, which means astronauts spend months stuck in empty space just for the trip itself. But now there's a new solution on the table, the Dual Direct Fusion Drive, or DDFD. It's a compact fusion engine that produces both thrust and electrical power at the same time. Inside it, deuterium and helium-3, 2 light gases, are fused together, the same process that powers the Sun, just on a much smaller, controlled scale. When these particles collide, they release massive amounts of energy, and that energy is what drives propulsion. The engine's actual design is surprisingly compact. Not a giant tokamak reactor, but a straight linear chamber instead. Powerful magnetic fields shape the plasma and turn it into a focused stream. That stream is then released through the engine's exhaust, protected by superconducting magnets, and it's this exhaust that pushes the spacecraft forward. The numbers here are genuinely impressive. Specific impulse, which measures propulsion efficiency, reaches 10,000 to 15,000 seconds. Chemical rockets only manage about 500. That means high thrust and high efficiency at the same time. That's the exact combination space engineers have been chasing for decades. But here's the most interesting part. The spacecraft using this engine, called Sunbird, doesn't even launch from Earth. It stays parked in orbit. Other spacecraft only need to reach orbit, dock with Sunbird, and the connection locks in place. That means the launching spacecraft only needs enough fuel to reach Earth orbit. Sunbird handles the rest of the heavy lifting. This approach dramatically cuts the total fuel needed for a mission, because the most expensive part, escaping Earth's gravity, is already done. The plan is for multiple Sunbirds to be stationed in orbit, a reusable fleet, ready and waiting for every mission. Once docked, Sunbird fires up its fusion engine and accelerates the spacecraft toward deep space. Now the real question, is this just a concept or is something actually happening? Here's the update. Pulsar Fusion successfully confined plasma inside Sunbird's exhaust test system at their facility. The test took place inside a specially built vacuum chamber, where engineers used electric and magnetic fields to guide and accelerate charged particles. Real-time data, thrust, exhaust velocity was recorded throughout to guide future improvements. This milestone was demonstrated live at Amazon's Mars conference in front of world-leading robotics, AI, and space experts. The company's next target is an in-orbit demonstration in 2027, meaning this isn't just sitting on paper anymore. There's a real timeline. For the engineers involved, this was a major moment, a decade of research finally producing a working proof of concept. If this technology scales successfully, the numbers are genuinely game-changing. Cargo delivery to Mars in just 4 months compared to 9 or 10 today. And Pluto? Currently almost a decade away, this engine could get there in under 4 years. This could also make asteroid mining missions far more practical. With less fuel pressure, spacecraft gain a lot more range. Deep space telescopes could also reach their Lagrange point destinations much faster. But let's be honest, this is still early-stage technology. The company itself admits these claims are conceptual, dependent on successfully scaling the system. Fusion technology has a long history of being just 20 years away, so some excitement is warranted, but so is a healthy dose of skepticism. If this actually works, it could become one of the biggest space achievements of our generation. What do you think? Will the 2027 test succeed? Let me know in the comments.